Hello everyone and welcome to episode 4 of my electrical age tutorial series. Now in this episode I'm going to be covering the fuel burning power generation, which that uses the heat furnaces and the turbines, and yeah, so let's just get into it. So first things first, you're going to craft yourself some of these combustion chambers. Now they're crafted with just 4 stone like that. It's very simple, very easy. Now the next thing you want to craft is some of this copper thermal cable. Now this is crafted with just 1 cobblestone and 1 copper cable, and that gives you 1 copper thermal cable. Now if you hold shift on it, it's got some stats there. So it's got a max temperature of 980 degrees Celsius. So once the temperature goes above that, presumably this thing explodes. And it's got some other stats there, so the serial resistance and parallel resistance. You really don't have to worry about those. Those 2 stats just describe the thing's thermal properties and how it carries heat, but you don't really have to worry about those in my opinion. Yeah, so it also has an alternative recipe that uses 6 cobblestone and 3 copper ingots, and that gives you 6 copper thermal cable all at once. Now the copper thermal cable works just the same as normal cable, except it's a bit chunky and thick, and instead of carrying electricity, it carries heat. Yeah. So next thing on the list is the stone heat furnace. Now the stone heat furnace is crafted with 7 stone, 1 combustion chamber, and 1 copper thermal cable. And it has some stats here, and that just gives you 1 heat furnace. And it has some stats if you press shift. So it generates heat when supplied with fuel, and its nominal power is 1 kilowatt, and its max temperature is 780 degrees Celsius. Now from testing and stuff like that, this it won't explode if it reaches that temperature. It can reach a temperature well above that without exploding. From experience, the stone heat furnace will explode around 1000 degrees Celsius. So I don't know why it says it has a max temperature of 780 Celsius. So I don't know. Maybe it's a typo or a mistake. I don't know, or it means something and I just don't know what it means. Yeah, so let's move on to the next thing. Actually, no, let's take a look at the stone heat furnace. Now, the stone heat furnace, when you get close to it, you can see the front of it opens. That's not quite nice. It's pretty good. It's pretty well animated. And it has some inputs on it, even though you can't visibly see it. On the sides, it can take a signal cable. So signal cable can connect to the sides of it. I'm going to cover the signal cable next episode. But the signal cable basically allows you to control this thing's power output remotely, and then its heat output is on the back here. So the thermal cable or turbine connects to the back, and then it's got this nice interface here. I'll explain this interface in a bit when I actually show off how the thing works. So yeah, let's just go to the next thing, which is the 50-volt turbine. Now the 50-volt turbine is crafted using 2 copper thermal cables, 1 machine block, and 1 electrical motor, and 1 low voltage cable. And it has some stats. So it generates electricity using heat, and its nominal usage is a temperature difference of 250 degrees Celsius. So you're going to want the difference of temperature between the hot and cold side to be 250 degrees Celsius. And it has a nominal output voltage of 50 volts. Your output voltage is likely going to be more or less than that depending on your situation. And your power output of 300 watts is, again, going to be more or less depending on your situation. And the thing has some inputs on it here. So it's got a red and a blue side. The red side is the side you're going to want to make hot, and the blue side is the side you're going to want to make cold. And then it has this thing in the middle, and this thing in the middle is where you connect your power cable to it. So it outputs power from both sides, and then it takes in hot thermal cable from the front and cold thermal cable from the back. And yeah, I'll show the thing actually working. So we have these other things here. So these are the thermal dissipators. So this is the small passive thermal dissipator. Now it's crafted using 6 copper ingots and 2 copper thermal cables, and that gives you 1 small passive thermal dissipator. Now it's used to cool down turbines, and it has some stats. So its max temperature is 200 degrees Celsius. So if this thing gets hotter than 200 degrees Celsius, it will explode. And its nominal usage is a temperature of 30 degrees Celsius, and it has a cooling power of 250 watts. So on its own, just sitting there, it will just radiate away 250 watts of heat on just sitting there. Now, it has another version of it, which is the small active thermal dissipator. Now, this is basically the passive one, but you stuck a fan on the top, and it's crafted with one small passive thermal dissipator, one electric motor, and 2 rubber, and that gives you one small active thermal dissipator. And again, it's used to cool down turbine, and it has some stats. So its max temperature is 130 degrees Celsius. It will explode after exceeding that temperature. And its nominal usage is a temperature of 30 degrees Celsius. It has a cooling power of 200 watts, but the cooling power will either, I believe it increases to 800 watts if you activate the fan. I don't know whether that 800 watts is the fan or is with the fan, or it's added to the 200 with the fan on. I don't know, but it's something like that. The fan voltage, it uses 50 volts, and the fan uses 50 watts of power. And you can see it's got this nice fan on the top, and this thing, of course, has animations. It takes in thermal cable from the big squares on the side, same with the small one, I should have said. It can take thermal cable in from any side. It will also, if you place two beside each other, these count as connected. And then, so the small active thermal dissipator, it has connections on the side for power. So if you connect a power line to it, the power will actually not only go into that small dot there and power the fan, but you could also put the cable coming out the side to power more of them or power something else. And it takes its thermal cable in from either side. It's thermal connections. Yeah, so those were all the things you need to craft your power system or your generator. But there's also some other stuff you're going to want to look at. So first of all, we have this thermal insulation. Now it's crafted with just 4 stone and 5 wool, and that gives you 4 thermal insulation. Now it's an upgrade for the stone heat furnace, and of course it's organic asbestos TM, trademarked of course, and it has a heat tolerance of 520 degrees Celsius. So if the temperature of the heat furnace goes above 520, it will the thermal insulation inside the furnace will be destroyed, and it provides an insulation value of 50%. There's also some other stuff here. So these are the regulators. I talked about these in episode 2 a little bit. So this is the on-off regulator 1%, and it's crafted using 3 redstone dust and 1 iron ingot. That gives you 1 on-off regulator 1%. Then this is the on-off regulator 10%, and it's crafted using the same resources, just in the same shape. I mean, different shape. Then this one's a bit different. This is the analogic. I don't know how to say that. I'm just going to call it the analog. So the analog regulator, and it's crafted using 2 redstone, 1 sheep chip, and 1 iron ingot. And this thing works a bit differently than those other 2. Yeah, so let's just go around to this side here and take a look at some stuff. So let's actually grab some of these. I also need to grab something else I forgot to grab. Let's just grab the copper heating core and plop it in there. So I'm just going to talk about these regulators for a bit here. So let's just put that in there, and let's put a regulator in there. Let's start with the 1% regulator, and then yeah, so you can set it to on. Now you can see it's not increasing. Normally when you set the thing to on, the thing increases in temperature, but it's not going to do that if you have a regulator in there. And with the regulator in there, you can now adjust this temperature gauge. So let's set the temperature gauge to, I don't know, let's just set it to like 220 degrees Celsius. Let's turn it on, and you can see it's going to heat up. Let's just bring this down to 100, just 110 for simplicity's sake and time. And you can see once it reaches close to that temperature, it should shut off the furnace. There you go. So the furnace is now off. You can see this better with the heat furnaces, but you can see, actually I'm going to use the heat furnace to display this, because the heat furnace, you can actually see the thing turning the furnace on and off. But this thing, the regulators will basically turn, you can set the temperature, and the regulator will try its best to keep it at that temperature. Yes, so let's take a look at the stone heat furnace here. So you can see it has some slots here. It has a slot for fuel, a slot for a thermal isolator, and a combustion chamber slot. So let's just grab some fuel out of there, some combustion chambers, some of those, and just one of these. And yeah, so let's put the on-off regulator 1% in here. Now the thermal insulation, let's just put some fuel in here. And let's just set this to what? Let's just set it to there. So when you press decline fuel, this thing will start burning the fuel that's been put inside of it. Now you can see the temperature is increasing here, and this gauge controls the amount of power. So you can see right now it's heating up at 240 watts, and here it's creating all 1000 watts of power. And yes, this gauge here just allows you to control the amount of heat it's making. So if you turn it off, you can see the furnace, it loses temperature after it's heated up. So, but if we put insulation there, you can see it loses temperature much slower. Let's take it out. You can see it's losing temperature fast. You put it in, it's losing temperature much slower. Let's heat it back up here for a second. There. So you can put combustion chambers in here. Now the combustion chambers allow this thing to make more heat. If we set it up here, you can see with the 2 combustion chambers in there, it's making 200 watts. So it's making what is it? 2000 watts of power. So the combustion chambers increase the amount of power this thing can make. So by putting 1, it increases its max power output to 1500 watts of power, and putting 2 in increases it to the full 2 kilowatts of power. Now it only lets you put 2 in. Let's put the insulation back in there. Now you can see this here is for the regulator. So again, let's just with the thermal insulation, you can see it's an upgrade for the furnace that stops it from heating up. Let's just make this thing heat up again. And you can see once it passes the 500 or whatever temperature, you can see it destroys the insulation. Now, if we put the regulator in there, we can set the temperature. Let's set the temperature to 300. And you can see it just turns the furnace on and off. So between 0 and between 0 and 100%, it turns it on and off based on the temperature. So it's trying to keep it at around 300 degrees Celsius. It's not perfect, but it's trying. Now let's replace that with the 10% one, and you can see it's not turning off as fast. So it's basically, I don't know how to explain this, but the 10% one, it's a lot less picky with the temperature. So it tries to keep the temperature within 10% of what you set it to. So it'll turn off, it'll turn on once it's 10% below your desired temperature, and then it'll turn off once it's 10% above your desired temperature, I think. And then there's just a minecart sound. I think that's how the thing's working, but you can see it's definitely not turning on and off as much as the 1% one. You can see the 1% one turns on and off a lot. Now the analog regulator, if we put it in there, it doesn't turn on and off. It will actually throttle it based on your temperature. So you can see there. So yeah, those are the regulators. They're actually pretty simple once you think about it. Let's just put that back in there, and let's just set this to like a nice, let's just set this to 110. There. So yeah, let's just set it to day so we can see a bit better. There we go. So you can see I have some of these dissipators here. So first, let's grab one of these out, and let's grab this cable. So you can see if I connect the cable to the back here, you can see this cable is now heating up. Let's set this to a more reasonable temperature of 300. And let's just keep it at the analog one. So you can see this cable, is now heating up with the temperature. But the problem with these cables is they're not perfect. So you can see the temperature here is 296, and then as you move on, you can see the temperature. Did it just go up? Why did it go up? Oh, it went down. But the temperature on these cables, it's not perfect. So if we make a let's just make it come out here. they lose a bit of temperature as they go. Now, they don't lose a lot of temperature, but they do lose temperature. So as this cable's heating up here. So it is a slight problem with these things, because if you have a really long one going somewhere, you're going to be losing some of your heating or cooling power. But they don't lose that much. Now let's just turn the heat down to something that won't explode our things. There. So here's the heat dissipators. So you can see this is at like, what, 200 degrees? If you put it in here, you can see the thermal dissipator heats up, but you can see it's slowly dissipating that temperature. So, yeah, and then this thing's going to increase its power output to try and keep up with this thing dissipating. Now, and if we break it off, you can see this thing is going to slowly decrease its temperature once we take it away from the heat source. Now let's heat up that cable again. Now here's the small active thermal dissipator. Let's just heat this thing up. It's taking a bit to heat up. Yep. There we go. So you can see this thing is around 90 degrees. Now if we take away its heat source, you can see the temperature will stop dropping. Not too fast, but it is dropping. So let's heat it up again. There we go. And then let's give it 50 volts of power, and you can see the fan will start to spin. And you can see that temperature is decreasing quite fast. It's now dissipating, I believe it's around 800 watts of power instead of just the 200. So you're going to want to use these. Now again, the power does pass through it. You can see the power does come out through, the power does pass through it, so you can chain these together. And then let's just turn that off. Just to show that it does, you can see the thermal power does transfer through the things, so you can make like rows, big, huge blocks of the dissipators if you so do desire. Now, let's just grab some stuff. So I'm going to go down here in this explosion-proof room. I'm going to show you the stuff reaching their maximum temperatures, because why not? I am going to have to turn off the shaders because it is way too dark to see in here. Okay, the shaders are off, and you can see we're in our little explosion-proof room here. Now let's just place down a heat furnace, and let's just place down I don't know, let's try to place this over here, and let's try to place this over here, just so I can show that that's the thing that actually explodes. So let's put those in there. Let's put some coal in here. Let's decline the fuel. Let's put one of these in here. And you can see the temperature should start increasing. And yep, I'm going to skip forward until this thing has reached a temperature where it's about to explode. Okay, so it looks like it's getting near the 200 degrees. 202. It should explode soon. Come on, don't let me down, explode. 200. It's past 200 degrees Celsius. It should be exploding. Come on, you exploded before when I was testing this. Why are you not exploding now? Bah, whatever. Let's try with something different. Let's try with this one. This has a lower exploding point. Let's see, are you going to explode for me? This thing explodes at the 130. Come on, explode. Don't let me down, explode. No? No, okay. Apparently this stuff doesn't want to explode now. This is a disappointment, but whatever. I had planned this all out before. I had tried this stuff earlier and it all worked. Don't know why it's not working now. But I guess life just do be like that. So let's just turn the shaders back on and head back up to the surface. Okay, we're back up here on the surface with the shaders on. And yeah, so let's explain how you can actually use these things to generate some power, because that's what we want to do with them. So you're basically going to you're basically going to want to hook up a power words are hard, well, for me anyway. Yeah, so you're going to want to basically hook up a heat source to the red side of the turbine and some sort of cooling to the blue side. Now let's just get this thing on. Let's put some fuel in here. Let's just put a regulator in there. You don't need a regulator, but let's just set this thing to like 200. This thing should begin to speed up. Is this thing on? It is on. Come on, generate some power. Oh. There we go. I need to tell it to decline fuel. Bruh. There you go. So this thing should... You can hear it is making a little bit of a sound. I don't know if you can hear it, but I'll try and boost the noise. There, I tried to boost the sound. I don't know if you actually heard anything. But yeah, so you can see we are generating some power now. But the power output is going to drop because this side is heating up. Yeah, so let's just turn on one of the active thermal dissipators. And that should make our, you can see I turned it on and our power went up there a bit. So it went down, now it's going up a bit. Now let's just increase this a bit more. Let's put some of those in so we can make more power. So there you go. So increasing the temperature a little bit and putting in those two combustion chambers made our power output go up quite a bit. But again, you can see our power output will eventually start dropping as this side heats up because we're getting around 40 degrees. So let's provide some more cooling. And you can see our power output is hanging around the 400 watts. So it's way more, it's like 100 watts more than the 300 watts it's set at outputs. But yeah, so the things really aren't that hard. Basically, put the cooling stuff here, put the heating stuff there, and power comes out there. Pretty simple. Yeah, so again, these things do have a max temperature. And if they go above that temperature, they will explode. I don't remember actually. Is it a temperature? I can't remember whether it's a max temperature where they explode or it's a power output amount where they explode. But you can see we're generating power and we're generating a whole 400 watts with just this one turbine. So way more than the wind turbine and it just stopped. Yeah, so this thing, it does burn fuel and it does burn quite a bit of fuel, but it does make quite a bit of power. So yeah, I think that's it for this episode. So like the video if you liked the video. Subscribe if you want to get notified to see more of my videos in the future. And thanks for watching.